NASA's SWIFT and ESA's XMM Newton satellites have used their X-ray telescopes to watch the interaction between a pair of gigantic stars. This is a stellar grouping called Cygnus OB2, one of the richest collections of hot, massive O-type stars in the galaxy. Unfortunately for optical astronomers, this spectacular sight is mostly hidden by dust clouds. One of these stars is a radio source simply called Cygnus OB2 number 9. In 2008, astronomers concluded that the changes in radio emission only made sense if the star were actually a binary, with two massive stars in a tight orbit. Massive stars run so hot that they actually drive away some of their gas in powerful outflows called stellar winds. In binaries with two large young stars orbiting closely, these hot outflows collide and produce X-rays. Only a few of these colliding wind systems are known, and they aren't especially well behaved for astronomers. The collision may become turbulent, and X-rays may appear only at some times in the orbit. Which brings us back to Cygnus OB2 number 9. It should produce X-rays where the star's winds collide, but there was no evidence for it. Perhaps it only occurred when the stars were closest in their 2.4-year orbit. The first opportunity to test this came during the close approach on June 28, 2011. So astronomers enlisted SWIFT and XMM Newton, as well as ground-based observatories, to monitor the system at intervals throughout the year. As the stars approach each other, their fierce winds crash together at several million miles an hour, reaching temperatures of millions of degrees and creating X-rays. As they separate, the collision strength decreases. Even so, these powerful winds will influence star formation in the binary's neighborhood. Cygnus OB2 number 9 has turned out to be a model colliding wind binary, one of the most reliable and best behaved now known. It will be a key to better understanding how these systems help shape the galaxy.